Hello, this is Jason with GoldSim Technology Group. I'm going to show you how to switch out a reservoir element with a pool element. If you're not familiar with GoldSim version 14, you should know that in this version we have added a new element called the pool element, and it essentially replaces the functionality that you might find in a water balance model that involves allocation or has multiple withdrawals from a reservoir or pond. And the way that you might see it in one of these models would be something like what you see on the screen right now, which is a pond connected to an allocator element in this fashion. So what I want to show you today is if you're upgrading your model to GoldSim 14, you may want to look into your water balance model and find places where you are modeling a pond or reservoir with the old reservoir element and replace it with the pool. It will make your model easier to understand and simplify it to make it easier to maintain going forward. It is definitely the recommended path forward if you are trying to upgrade your water balance model. Okay, so the first thing I want to do is add the pool element and essentially replicate um, the input definitions for this element that are similar to the reservoir. So I'll add the new pool. You can see it looks similar, but it has a slightly different icon than the reservoir. And I'll give it a similar name for now. I won't be using this anywhere, but I'll just put that in there. And, and then I'll go ahead and start filling out the input definitions. Um, I probably should put a description. Okay. Uh, so I should probably call this outflows. Okay. So if you're new to the pool element, I suggest that you click on the help button here when you open up the pool element and read about it. Um, Again, it is similar to the reservoir with the exception that it will allow you to um, provide inflows and define the allocated outflows all in one element, making it a lot more simple, easy to understand than the current setup. Okay, so I'm using cubic meters for volume and cubic meters per day for my flow units. And then that's for now, that's all I know. I'm going to close this and go back to the reservoir element and see what I have. For initial value, I have a knit vol and then pond capacity for the upper bound. I'll go ahead and put those two things in here. Same thing. Knit volume, it has an upper bound called pond capacity. Okay, I've got those two things copied. The next is the inflow. There's three inflows there. That's these three up here that are shown in green. It's always a good idea to organize your model so that it's easy to find where your inflows and outflows are coming and going. All right, so I'll just add these one at a time. Return flow, inflow from river, pond 3 return. Okay, I replaced the inflows. Let's go back to the reservoir and look at the outflows. Pond 2 request and evaporation request. The reason we have requests here is because sometimes you have an outflow that if the pond runs out of water, it cannot supply the outflows. So it could be limited. So that's why it's always good to first define your withdrawals as requests because you don't know if you can get them. The nice thing about the pool element is I can define them individually instead of lumping them together with a sum here. So I'll go ahead and add the requests here into my outflows. I'll have two of them. I have two outflows from my pond. The first one is the evaporation, and the next one is the discharge to pond 2. Okay, so I have an element called evap request. that's just linking over from this container called pond controls. It doesn't even matter so much as long as I make the outflow request exactly what I have in the reservoir. The next one is the pond 2 request. There it is. And then, okay, I can go into this container to see them. They're located here, pond 2 request, evaporation request. The evaporation request is a function of the area, the surface water of the surface area of the pond water surface, and then the pump request is actually looking at pond 2. Um, so I should probably also mention what what this model is doing. If I go up a level, you'll see that this is a model that has 3 ponds in it. Here, there's a river. We divert water from this river over to this pond. Overflows go to this other pond 3. Um, as pond 1 starts to dry up, it will request water from pond 3 to come back. And then also the main purpose of this whole system is to feed water to the demands A and B. So water then will continually be as often as it can. We'll be pumping water to pond 2 to keep it full in order to supply water to A and B. And pond 3 is just a regulating reservoir to just provide more storage. And there are return flows. A portion of those must come back to pond 1. So that's essentially the flow network. You can find this example on our webpage if you go to our help center and then go to Model Library Applications, Water Management, and you'll see an article here called Network of Interconnected Ponds. And it describes it, talks about the model. You can download it here. Okay, so this is the model, and I'm inside this container called Pond 1. All right. So I'm almost ready to do the switch. I'm going back into the reservoir just to make sure, review everything I have. Two withdrawal requests, and I have 3 inflows. So I'm going back over here to the pool element. I have the initial value the same, upper bound the same. Inflows, I've got those 3 inflows. Outflow requests, I have those 2 requests, and I think we're pretty good. So now it's just a matter of removing and replacing. So I'll go ahead and just remove this old pond here, bring this back over here, make sure it has the same name, click OK, and then I'll hit the F9 key, or I'll go up here to Model, Update Expressions, and you'll see I've got a couple of issues here. That's just because of the way that there's a slight difference in how the new pool element will present, or how it names the overflow. It's not called overflow rate anymore. It's called overflow. And same thing goes on here with the withdrawal rate. However, because we're using a pool now, I'm just going to completely just get rid of this allocator. It's no longer needed. So I'll remove the allocator. Now I'll go back into these outflows of the reservoir. We have the pond overflow. I just fixed that one. The evaporation rate is going to look a little bit different. It won't come from the allocator anymore. It is now directly on the output of the pond dot evaporation. And that is because if I go back in here to the outflows tab, you see there is this name evaporation. It is looking for that name. Okay, next one is discharge to pond 2. All I need to do now is just change this name to pond, and it finds the discharge outflow. So now I have connected. If I go in here to the output port, I can look at the outflows in the outflow container. These are the 2 outflows that I created, evaporation and discharge. So those are the 2 that I'm linking to in addition to the overflow. And you can see which ones I'm linked to here because there's a little dot next to the triangle indicating that this output is being used, and it's being used here, here, here. I also refer to the volume as information for other components to be referencing. So for example, over at pond 3, I need to be watching how much water is in this pond to tell me if I need to send water back over here, that kind of thing. All right, the next step obviously would be just to make sure that we can update all of our expressions. So I'll go here to model and update expressions. Another thing I can do is go ahead and just run the model, make sure that it works. We do have some warnings, and I'm guessing the warnings all have to do with removing that old element. If I go here to this time history chart, it used to show this output here that came from that old allocator. I'm just going to delete that. If we want to look at volume, let's see, we have that. It looks like we have most everything still intact here because I was linked to other elements, not linked directly to the pond to look at that information. However, when I run the model, I am still seeing 2 warnings, so I want to see what those warnings are. Go down here to the bottom and it looks like it's a different result, one that's called reservoirs plot and one that's called pond one. So I'm just going to go up to in the top of the model, go into reservoir model results, and one of them that had issues was this one. I'm in result mode, so I'm just going to right click, go to properties, and then I'm just going to reconnect to the pond element that I just created. That's this new pool element. Replace, it goes blue again. The other one was in this pond one. Oh, because I'm in result mode, I need to right click, properties, and then I can just hit the previous here to get back to the same place, except, great. Now I should be able to view the chart by double clicking, and I can. It looks good. I can also go up here to the dashboard, and I should see that pond one, which is up here at the top, it is still showing the correct chart, and it looks to be working correctly. So everything is in working order. I think in a real model, one more step you would want to take is probably before you switch them out, you'd want to record your outputs, maybe put them into a new table, a time series input, for example, and then you could then compare the results with the new element against the old, just plot them together and visually compare, or you could even take the absolute value of the error between the two, and they should be the same answer. We don't expect any differences there. But that concludes the process of um, switching out a reservoir element with a new pool element. Thank you for watching.